This is question number 6. This question has a lot of reading in it. It's also about two very similarly named pesticides. One of them is called Kilpest and the other one is called Pestkill. Now, to keep things nice and simple, from here on in, I'll write about Kilpest in red and Pestkill in blue. I've also separated the page down the middle just to keep things straightforward. So the question says, trees are sprayed weekly with the pesticide Kilpest, whose manufacturers claim it will destroy 60% of all pests. We're told that between the weekly sprayings, it is estimated that 300 new pests invade the trees. This is a recurrence relation question, so the first thing we're going to do is try and write a recurrence relation for Kilpest. So we have U n plus 1 equals, now we're told that the pesticide Kilpest destroys 60% of all pests. That means that 40% of the previous week's pests return. So putting that into a recurrence relation, 40% is written as 0.4 in our multiplier. That's 0.4 multiplied by the previous week, which is UN. And we're also told that every week 300 new pests invade the trees. That means 300 pests are added. So what we have now is we have a recurrence relation for Kilpest. If we go on to read the next part of the question, we're told that a new pesticide, Pestkill, comes onto the market. We're told that the manufacturers claim that it will destroy 80% of existing pests, but we are also told that it is estimated that 360 new pests will invade the trees every single week. So what we want to do now is write a recurrence relation for that situation. So again, starting with UN plus 1. So we're told that this pesticide kills 80% of the pests in a week, which means 20% of the pests return, and that is written as 0.2 in a recurrence relation. 0.2 times the previous week, which is UN. And with this pesticide, we're told that 360 new pests invade each week. So that means 360 pests are added. So we have two recurrence relations, one for each situation. The question asks us which pesticide will be more effective in the long term. So as soon as you see the words in the long term, that should make you immediately think of working out a limit. So what we want to do is work out a limit for each situation if a limit exists. So looking at the first one, our multiplier here is 0.4. Now that does lie between -1 and 1, the conditions for a limit. So this situation does have a limit. Again, our multiplier 0.2 lies between -1 and 1. So we also have a limit for this situation also. So if we work out the limit for each one, what we'll get is the amount of pests that will remain in the long term. So the question says which pesticide will be more effective in the long term. So the one with the lowest limit, in other words, the one that has the lowest amount of pests remaining, will be the more effective pesticide. So we're going to work out the limit for each. The one that has the lowest limit that one is the best pesticide in the long term. So looking at kill pest first and writing down our limit formula. So L, the limit, equals B divided by 1 minus A. And that's where A and B are the numbers indicated. A is 0.4 and B is 300. So substituting those in, we have 300 over 1 minus A. So that's 1 minus 0.4. That gives us 300 divided by 0.6 and 300 divided by 0.6 equals 500. So the amount of pests remaining in the long term with kill pest is 500. What we want to do now is the same thing again, only this time for pest kill. So once again, starting off with our limit formula, where A and B are the numbers indicated. A is 0.2, B is 360. So substituting those in, that gives us 360 over 1 minus 0.2, and that gives us 360 divided by 0.8 and 360 divided by 0.8 equals 450. So that means that using pest kill, the amount of pests in the long term reaches a limit of 450. So the most effective pesticide out of kill pest and pest kill is obviously pest kill with a lower limit, a lower number of pests remaining in the long term. So we have to explain that in a sentence. Pest kill is more effective in the long term as we have less pests remaining. This is indicated by the lower limit. And that is our final answer.